Hey everybody, this is Breaking Down Security. Welcome back everybody, this is Brian and Mr. Boettcher for Breaking Down Security.
Hello.
Been a serious last couple of weeks. I mean, we had Mr. Tim Wood, or as I like to misspell his name, Time Wood on LinkedIn. Oh God. What is it, man? I don't know what it is about me and posts. It's like Time Wood, and I'm like, ah. And
well, it's you and names, in any format, verbal or written.
I know. I shouldn't try posting things at 11 p.m. at night after I'm about half asleep and trying to do things. So, but Tim Wood.
Are you a boozer? You're a boozer?
No, I'm not a boozer. I just I'm not as young as I used to feel. So,
yeah.
But yeah, Tim was great. I appreciated his insights into ITIL, and it was great listening to him talk about something he's obviously passionate about. Because I mean, he was passionate enough to make a 41-slide presentation on ITIL and how it works with security. So that's some passion, man. I'm telling you. Just
for the podcast too.
Yeah, I know.
That was excellent.
Yep.
So yeah, I mean, how it lines up with security programs and IT service, in general. I know I've been a part of companies who did it right and companies who did it wrong. And it is such a relief to be able to, to rest assured that if you put in a ticket for an issue, that somebody's going to look at it in a timely manner, and you won't have to spend most of your time chasing down people.
Yeah. And it's one of those things. I didn't realize ITIL was it could be phased in, or it can be done piecemeal, or it can be done in a smaller scale format than business wide. You could have a whole division just based on doing what's ITIL, or picking certain parts that to make sense to your organization. So
right,
yeah, I liked that. So, Mr. Boettcher, what are we doing this week on Breaking Down Security?
I think we're going to talk about buffer overruns.
Oh God.
We're going to get back to our roots and get a little technical here, and talk about something that I think all security people at least should be aware of. Maybe not be able to get down in code or do a code audit to look for these things, but when somebody talks about buffer overflows, buffer underruns, you should know what that is, and to be able to speak the language, right?
Yeah, somebody's going to get technical, because I do not come from a programming background. That would be Mr. Boettcher, who got his computer science degree from some college, University of, Texas at Austin, or some place like that.
Yeah. So, yeah, coding is my background. I was a level 1 developer before I moved into, the management and the support space, and then got into security after that. So yeah, I do a little bit of coding every once in a while, and buffer overflows is something that I look for regularly, And if I'm just coding up a quick script or something, I might put a comment. Hey, this has a potential for a buffer overflow, like if I hard code a value, something like that. That way, if I turn it into something bigger later on, I'll know, oh yeah, I got to look at this. Or if somebody else is going to review the code, I might want to fix that before I hand it off.
Yep. So when we first started looking at this, kind of a little behind the scenes here, he said, oh yeah, we're going to do buffer overruns. And I was like, wait a minute, buffer overruns. That's what I used to have issues with on CD burners or whatever, when I would, when the data wouldn't fill the buffer quick enough, and it would, mess up all my CDs and DVDs. He's like, no, buffer overruns.
Yeah.
And then he gave me this book. It's called The 24 Deadly Sins of Software Security, Programming Flaws, and How to Fix Them. We'll have this a link to Amazon in our show notes. Written by Michael Howard, David LeBlanc, and John Viega. Michael Howard is kind of a big deal at he was or is at Microsoft, where he does a blog, and I'm not sure.
Let's just say he was there, since we want to kind of make this episode timeless, right?
Yeah. Oh, true. Yes, he worked at a company at one time that he may not work at now,
In the future.
or in the future. Yes. But yeah, you can find him online. He had a blog. He may still have a blog. He may have a blog in the future. There you go. Is that future proof enough for you?
That covers it.
All right.
So, what is a buffer overrun?
Yes. What is a buffer overrun?
Well, a buffer is like allocation in memory. Typically, it's a block, sequential block in memory, and they call it a buffer. Okay, it's like an array.
Okay.
You hear of string buffers or whatever, but it's really an area in memory, sequential, that you put or store values. Now it can be stack or heap, and we'll get into that, but it's basically an array of values, and that array has a fixed size. And what a buffer overflow is somehow you get outside of those bounds that an array is. And in lower level languages like C, you can actually overwrite memory, and we'll talk about some of the ways you can do that. So you can actually read memory from outside of the that array.
That sounds like what was it? Heartbleed was a buffer overflow kind of thing, or a buffer overrun kind of deal, wasn't it? Where you take a request and say, okay, this value had 8 bits, but I expect 150 back or something, and it would read everything in the first 8 plus the remaining extra bits that were in memory. So it was overflowing the buffer and sending back 150 bits, right? Is that type of buffer overflow you're talking about?
Don't get me lying. I don't remember the technical details of that, but yeah, if it is as you described, that would be a buffer overflow, certainly.
Okay.
And I think the terms are used synonymously. I was looking at what's the difference between an overrun and a overflow, and some websites said it's the difference between reading and writing. I'm not sure. Mm-hmm. I think the definitions are pretty much synonymous. And in the book 24 Deadly Sins, the chapter is called Buffer Overruns, but the examples they give from CWE. And what is CWE, by the way? We'll get into that. And then they say, all the examples are buffer overflow.
Okay, so I looked on the Wikipedia while you were explaining that, and it's Heartbleed was a buffer overread. It is an anomaly or program while reading data from a buffer overruns the buffer's boundaries and reads or tries to read adjacent memory. It's a special case of violation of memory safety.
There you go.
So it is a kind of buffer
So we'll talk
overflow.
we'll talk about some different types, not all, and then we'll get into an example or two, and then what do you do to help mitigate this, mm-hmm. All right, or detect it.
All right.
So let's go into a few different types. We have stack-based buffer overflows. Now, the difference between the stack and the heap is the stack is known at compile time. So when you compile your code, everything that's known goes on the stack, and everything anything that's not known at compile time, say you read from a file values, then that'll go on the heap. So stack base is your buffer's placed on the stack, and it's typically a hard-coded size. And then one way you can get a stack-based buffer overflow is if you have some sort of an input from somewhere that's a variable size or that you don't trust, right? So if you do read in a file or user input and stick that in the stack, that could overflow. So for example, you put in, you build an array of size 10, but you read input from the user that's more than 10, well, you're going to have an overflow if you're not checking for that condition and saying, you exceeded the boundaries, why don't you try again? That kind of thing.
Mm-hmm. Okay. So the idea is if you have you can set variables equal to so many bit lengths.
You can, well, like if you have an array of 10 values, now those values could be different sizes, like a wide character, like a Unicode or a regular character, that kind of thing. They come in different sizes, and the compiler will know how big how big each one of those is. But typically it's a numbered value, right? As to how long this buffer is, according to what size of thing you're going to place in there.
Okay. And you said that so a stack is what happens
At compile
at
time.
compile time. Okay, and a heap is post compile?
Yep, runtime.
Okay, so when you're compiling the program, you can actually cause buffer overflows, and after, let's say, the code is run properly and it compiles properly, just the execution of it can cause additional heap overflows on the back end.
The stack is what is used or known at compile time.
Okay.
That the compiler knows about, and then the heap would be anything that is unknown at compile time, and it's basically runtime storage.
Okay.
So two different things. You allocate memory and deallocate memory. So in C, if you allocate memory on the heap, you need to deallocate it, and that's where you can run into memory leaks. If you don't deallocate memory on the heap, the compiler knows about stuff that's on the stack, so it's going to deallocate it properly. But stuff that it doesn't know about, you have to do that. And that's where, like, things that Java does well is it has a garbage collector, so you don't have to worry about that kind of thing.
Okay.
Yeah, so a heap-based buffer overflow is something that's memory that's dynamically allocated, and then that overflows. So it's very similar, except it's on the heap. That's the only difference.
Okay.
So yeah, you get, maybe you would allocate the size at runtime. You don't know it ahead of time. So maybe user input, and then you take more user input or hard-coded values that exceed the values that you built on the heap.
Okay.
Yep.
So
and then there's
okay,
go ahead.
I'm sorry, because I am absolutely not completely lost, but I understand. So when you're compiling code and you have known values, those can cause stack-based overflows. But when you're compiling some code, you have known values and unknown values. The known values can cause the stack-based overflows, and the unknown values, which are dynamic or in flux or can be set after you've compiled the code, can cause the heap-based overflows.
That's right.
Okay.
And
I'm only asking for clarification because I'm sure there was somebody out there who was like, huh? Because, we're not all coming from programming backgrounds. So
just one clarification of what you said. The stack-based overflows, they're built on the stack, but they could take user input that would overflow that at runtime. So it's located on the stack. The memory is.
Sure.
However, the program is accepting user input for that memory allocation on the stack.
Okay.
You could get things like, I don't know, maybe if you let's see, we don't have an example like that in our show notes, but what comes to mind on a stack-based overflow is maybe you do recursion and you have an infinite recursion or something that overflows the stack that way. If you do recursion that's too large for the stack, you're going to get a stack-based overflow there.
Okay.
And then next is buffer underwrite. It's basically referencing memory locations prior to the beginning of the buffer. Okay, so if you do some calculations and you end up going like less than 0, right? So you allocate memory and you're trying to read something that's under what you've allocated. That's called a buffer underwrite. And I don't really see a difference. Under, over, who cares?
Now, if you're
right? They're the same.
if you're underutilizing a buffer, how's that a bad thing?
It's not underutilizing. It's trying to access memory. Like, say you have an array of 10 values and you want to try and access -1, let's say.
Yeah, you can't access -1.
Yeah, so that's what I think is meant by buffer underwrite.
Okay.
Prior to the beginning of the buffer.
I see.
And then, of course, you have your off by 1 error. You know what that is, right? Off by 1.
Is that trick?
It's
is that
pretty
a trick
common.
Question?
No, it's not a trick question.
Okay.
So yeah, off by 1. It's pretty common. People say, damn it, off by 1. It's the size of your buffer is miscalculated. You're missing like, say if you have a character array that's null terminated, you're missing that null character, or you use, instead of using less than, you use less than or equal to, or vice versa, things like that. That's the most common, is you're using less than or equal to instead of less than, or you started from 1 and not 0. Right?
Okay.
Because, in programming, you always start with 0,
okay.
right?
Yeah. All right. I get that.
So sometimes that can get the best of us, right? And you get that off by 1 error, so that's what that means.
Okay.
Then you have a wraparound error. All right, so every type in programming has a particular boundary, right? So an int in C, integer, has like 32,000 values.
Okay.
In the positive area, and 32,000 in negative. So you can go from negative 32,000 to positive 32,000. And it wraps around. So if you're at the max and you add 1, it goes back to the negative number.
Okay.
Negative 32,000.
So
right?
if you add 1 to 65,535, it'll go to negative 65,535, and that's a bad thing.
Right. So an unsigned integer goes to 65,535. And what's the 65,535 that you know?
That's the number of ports in a TCP/IP stack.
Right. So there's 65,535 of those, and there are no negative ports.
Yeah.
Right. So an unsigned integer is used for that. So if you add 1, like say you have a unsigned integer, and you've already gotten to that value, and you add 1 to it, it rolls back to 0.
Okay. Very nice.
Right. So those are the types of errors programmers can run into that may not be known to them, but at the time, but then hackers can take advantage of it by, putting in values that exceed those boundaries. So then you have improper validation of an array index, right? So it's what I was saying earlier, where if you have somebody input, if you have an array of 10 values and somebody inputs, well, I want 12, well, they've exceeded those boundaries, and the programmer is not doing that check to make sure that they get input from either a user or another function, anything like that, that they're within the boundaries of what they're trying to do before they keep executing commands.
Okay, so an array for a command might be the list of arguments that occur after a specific command. Say, like when you're running nmap or something, and you have your dash v dash n dash pn or whatever. If nmap is only allowing you 4 values and you try to put 5 in, it should error out properly. But if you're not setting your errors, if you're not setting your array index properly, it can cause overflow.
Yeah, if you're not doing that checks to make sure you're only getting 4 values, then you could have unintended, execution.
Okay.
Right. So that's kind of security 101. Basically, security is all about making sure that you get the proper inputs to execute the program, right?
Yeah.
And hacking is you're giving the program inputs that are unexpected,
Okay.
right?
So somebody who does not come from a programming background like myself, you actually have quite the leg up. You are the type of person that security companies are looking for because you understand code, you can write code, and you can also penetrate, do pen testing of applications and go, okay, well, I can look at this code and tell that there's a buffer overflow here, or that there's you've got an off by one here, and that's going to cause you to have issues. So you're kind of a
Yeah, I
rare
mean,
deal.
when you do, when you have some, obviously when you have someone that needs to be doing code audits, they have to understand code. So yeah, it all depends on the job that you're doing. If there's a role that can be filled like that, sure, with a programming background, yeah, it helps you to be able to do those types of code audits. And when managers are looking for somebody to fill those types of roles, they're definitely going to want somebody with a coding background there. To be able to make sense of and talk to developers and make sense of their code, right?
Yeah.
All right, and there's tons of examples that we can go through. Let's talk about the CWE, right?
Sure.
The Common Weakness Enumeration.
Yeah.
Right, that's a website. You want to speak to that?
Well, yeah, the CWEs were created by MITRE.org, which also create the CVE, which is the Common Vulnerability, and it's not enumeration, is it? It is enumeration. Or no, Common Vulnerabilities and Exposures. I did this before. I did this once before when we were talking about CVEs. I called it Common Vulnerability Enumeration or whatever, and I got the CWE and the CVE mixed up, but it's actually Common Vulnerabilities and Exposures list. So
old habits.
Yeah, old habits. So this is the CWE in this case, or Common Weakness Enumerations, and these are basically showing you it's a measurable set of software weaknesses that allow you to enable effective discussion and use of tools that can find weaknesses in source code and operational systems. So basically, it's a list of what was it? The 2.8 version of the CWE's got like 1,500 pages in it of different common weaknesses and vulnerabilities. And what the book that we're referencing here takes all 1,500 or so of these and puts them into 24 categories. And some of them are like...
I don't know if it takes all of them. These are the 24 most deadly. So if we have, like we're doing buffer overflows, it'll give you some examples like a subset, but I don't think you can fit all of the common weakness enumerations, all 1,500, and stick them into 24 categories. These are just the deadly sins. I'm sure you have some not so deadly sins out there that don't fit in these categories, but 1,500 of them, that's a lot.
Yeah.
Just to fit into 24 categories. So, if you have, if somebody mentions something about, programming that you don't know about, you could go to the website and type in that vulnerability, and it gives some great examples of code. If you can read that, and explains about how one would go about, number one, coding that particular vulnerability or weakness, and then number two, give examples, and three, offer suggestions. So it's a really good resource to look at when you're doing code reviews or talking to developers about a certain vulnerability that you found.
Yep.
And you may not know. They may say, well, I have no idea what that is. You can go to this, or have them go to this and find out more about it.
Yep, and some of the things that it talks about, the weaknesses span not only software vulnerabilities, but there's web vulnerabilities. Like, for instance, CWE 384 is session fixation, which is a web vulnerability that we've talked about in our OWASP top 10 discussion.
That's right.
There's, let's see, 431 missing handlers. There's it actually has the OWASP top 10 in here at one point. I think it's like...
I saw one that was number 1,000 or whatever. I'm just making that up.
CWE 711 through 723 are all the OWASP top 10s from 2007 and 2004 broken down. They have it seems like that this is just a massive list of different types of vulnerabilities, sometimes broken down by web, or I mean, they even have like sections on Java and struts and J2E.
Now, to be fair, they're not going to have, at least I don't think so, they're not going to have Heartbleed in here, right? They're going to have the category that Heartbleed was,
Exactly.
or what caused Heartbleed to happen.
Exactly.
So you're not going to go in here and find a specific vulnerability for, some off the wall Linksys router. No, you're going to find what caused that vulnerability in that router, whatever it was.
Yep. Yep. I can't believe we're at 25 minutes right now. I mean, it's pretty much been the Mr. Boettcher show, and I appreciate that, because this is something that I know you're extremely interested in, and it's something that I want to be interested in, but it's like waterboarding for me. I tried reading the chapter that you told me to read, and I'm reading it, and it's just going right over my head, because I don't do coding. I think I did a Java class in my University of Phoenix course 5 years ago. No, probably 8 years ago. And unfortunately, a lot of that's just kind of power dumped. And I'd really like to learn how to do code audits and do code audits successfully, because I've worked at several companies where I think that could have been used to great advantage, because either code audits are being done with an automated tool, which, most automated tools do okay. They find, say, 50 to 60% of the glaringly obvious stuff, but there's a bunch of stuff that makes it by because it's syntactically correct, but may not necessarily be programmatically correct,
Yes, those flaws are hard to find, and they can't be automated in in a lot of cases. Now, I have seen some printouts from these mechanisms, and I think it's very valuable, because you could see instantly, we have a potential buffer overflow here. So then you could either go look at it yourself, or tell the developer, hey, there may be a buffer overflow. Can you check it out? And they're being like, what's a buffer overflow, or something like that. If you get that, then you can study up common weakness enumeration,
Yep.
or have them go to the site and look it up as well. But at least you'll know, I don't expect everybody to be able to identify buffer overflows, but at least know what they are.
Yeah.
Right. And that's the purpose of this podcast, is to get security people to know what some of these, deadly sins, if you will, or weaknesses in code actually is, and some of the things that can be done about it. Now, you've heard of string copy, right? That
Yes.
string copy came about, maybe a couple years ago or whatever, and it was a bad thing. You shouldn't do that anymore. Well, why? Well, can you guess why we don't use string copy?
Because
It might have a
buffer overflow.
Overflow,
Might cause
yes.
buffer overflows. Yes.
It might cause a buffer overflow. Yes, it's unsafe because you could potentially copy values to a buffer that isn't large enough to hold them.
I see.
Right? That's why. So I think Windows, or maybe the C++, I think it was Windows though, that did strcpy S, which they created to kind of mitigate it, where you have to explicitly specify the size of the target buffer, right? And that's pretty much all that did there. But if you practice good coding, you wouldn't have had that problem anyway.
Yeah.
I was doing some C code the other day, and I just kind of found some reference in I Googled for it. Oh, okay. Let me try this. So I copied it into my compiler, and it blew up and said, sorry, it's using string copy. I didn't even read all the code.
Yeah.
Because I was just testing. We're not going to do this. And then I had to go through and, okay, let me replace all the string copies with string copy _s, and then my compiler was happy about that.
Nice.
So, and it wasn't as simple as strcpy -s, because I had to go and either hard code the values or create constants or whatever it was to create that new value, which was the size of the target.
Okay.
Right.
Okay.
So what do you do about buffer overflows, right? How do you detect them? As security people, we need to be able to detect buffer overflows, right?
Sure.
In some cases. So you could make sure that proper input validation is happening. So if you have a function in some code that just trusts that someone puts in those values properly, um, everybody in our industry should know, don't trust anybody,
Yeah,
right?
exactly. Exactly.
Yeah. So if you go to that website, don't trust them, or if you accept user input, don't trust the input. You have to do checks. You have to validate
Yep.
what your inputs are. So one of the early languages I used was C++, and it has containers, which are unique to C++. They're not in C, but they're things like vector, list, that are pre-built. So instead of creating an array, you would create a vector, and it has all those checks in it, so you don't overflow those buffers, right?
That's interesting. So is that something that is C++ specific, or do other programming language? Obviously, C doesn't have that, because one thing I did get from this chapter was that C should only be used for like the lower level functions of the program, while C++, say for user functions or whatever, should be using C++ for that, because you have those kinds of memory protections in place, and additional goodies that can be used to secure the code.
Yeah. So, for example, if you're using vector, it has those checks in place to where if I can use like a function called pushback, where I'm just pushing another value on to the end of the vector, and what it does behind the covers is it doubles the size of the vector if it didn't allocate enough memory to begin with. If you create a vector, let's say it creates a value of 10, and even though you may use 1, 2, or 5 of those, but if you start putting more things into the vector, and you exceed 10, it'll create a new array of 20 behind the covers, and create those safeguards there.
Okay.
Yep.
Wow. Well,
So go ahead.
I would love to go an hour long with this, and maybe we'll turn this into another part of a podcast the next time. But due to time constraints, we're going to have to kind of cut it a little short here. Is this something you want to do again next week for a podcast to kind of expand upon what we've learned today?
No, this is enough. I mean, I just wanted to educate myself and others like you on what buffer overflows are, so we can have a better foundation for security, right?
Sure. And as big a deal as this is, I'm sure we can come back to it at any time and talk about it. Because there are things that we did not talk about, like certain protections in the compiler. There's certain things in the OS levels that can help protect, like ASLR and DEP, which is dang it, I have it right here. Protection.
You can do fuzzing testing.
Yep.
You can do boundary value analysis. You can use address randomization. Just all kinds of things to help you detect and prevent buffer overflows.
Yep. So I know at some point we will come back and talk about those various things. But we had 2 long podcasts the last 2 weeks, so I thought maybe we'd have a little shorter one this time. So yeah, that was great. I learned a lot about what I don't know. So I need to definitely
there you go.
I need to find some nice little program that I can go through and look at, and there are code examples in the book. So if you are really wanting to understand that kind of code, you can get the book. I think it was like $30 on Amazon. I'll have a link to it in the show notes here. So
yeah, I think it's a great book and a great reference as well.
Yeah,
and it's something I keep around in case I'm looking through, a report from some of these programs that do code audits, and I see something I can look in here and refresh my memory, right? And something you mentioned before, the more you know, how much you don't know. I mean, it seems like the smarter you get, the more you realize how incompetent you really are. I think that's true.
Oh yeah, yeah. I definitely know that. That's pretty much the last big stumbling block I have is understanding code and stuff like that. I think so.
All right, is that a wrap?
I believe that is a wrap. That was it for breaking down security this week. You can find Mr. Boettcher and myself on Twitter at Brian Break and at Boettcher Pwned. BOETTCHERPWNED. I just, it's been about a week since we started our Patreon. That was kind of a big deal. And we already have one person on there, somebody named Brian from Seattle. Weird. Shout out to Brian, I guess.
Sweet.
Yeah. So we have a LinkedIn page, Breaking Down Security on LinkedIn. You can find us there in the groups. Facebook fan page is facebook.com/breakingdownsec. And if you're in the Seattle area, myself and Totenkopf on Twitter have a group that we get together and go to restaurants in the area. And it's called CSEC East. And you can go to meetup.com and search for CSEC East and sign up and come out and have some dinner with us and have some light conversation, with, like-minded security individuals. And, it's good times. We just had our third meeting last month, and it was a lot of fun. So we try to have it the first Tuesday of every month. And if you want to, come out, have some drinks and meet some people and network in the Seattle area, please feel free to hit us up. So that was it for Breaking Down Security. Mr. Boettcher is always available for comments, questions about coding and stuff. So you can hit him up at bds.podcast@gmail.com. So everyone have a great week, and we will talk to you later.
Bye-bye.